Okay, so idea of a function, there is a activity in your textbook. Do you bring your textbook? Of course not. I didn't ask you to bring, right? But it's okay. I've got it over here. So this is what we are going to be doing today. As mentioned, this is like a vending machine. We've got an input and an output. Over here, our input, value of x. According to this, they put in 5. Then something happens in the vending machine and it gives us 8. So this is just an example of a vending machine. Huh? You put in 5, you get 8. Put in 10, you get 13. Put in 15, you get 18. So on and so forth. Can you guess what is the relationship? What's the relationship over here? What is this rule over here? Plus 3, is it? What plus 3? Input plus 3 equals to output. Output they call it y, right? So you can say that y equals to x plus 3. So that's what's happening over here. Y equals to x plus 3. Okay, let's take a look at the next machine. Activity number 2. So here we've got input and output again, but this time input is 2, in other words the x value. They input 2, they give you 5. Input 3 gives you 7, so on and so forth. So copy and complete the table, very simple. The output is simply 5, 7, 9, 11, 13. Get it? So let's move on to the next part. If we let x be the value of the input, like I said earlier on, then y will be the output. Then you can form an ordered pair like this, x and y over here. This is like what we've been doing on our graph paper, x and y values. Form the ordered pair for the values of the input and output above. Form the ordered pair. So the ordered pair actually looks like this. These are the ordered pairs. For x value of input 2, we get 5 as the output. Input 3, output 7, so on and so forth, so on and so forth. Next, part B. It says plot the ordered pairs on the given coordinate plane. So in your textbook, there's a coordinate plane. I think you can do this. So this is after plotting. Okay, all the crosses over here representing the block 2, level 5, block 3, level 7, so on and so forth. Next. Do the ordered pairs lie on a straight line in the coordinate plane? So imagine you have to join them up. Do you think you'll get a straight line? Looks like you'll get a straight line, right? You can actually join them with a ruler. You get a straight line. So the answer is yes. Okay, next. Now suggest an equation that shows the relationship between the input and the output y. Let's go back to the table of values. Over here. Can you suggest a relationship? How is input related to output and vice versa? What did they do with the input to get the corresponding value of the output? Can you make a guess? Any guess? Searching, what do you think? Input times 2 plus 1. Okay, let's check. 2 times 2, 4 plus 1, 5. 3 times 2, 6 plus 1, 7. Oh, yeah, it looks like she's right? So yes, that's the relationship. It was a guess. So here, we have output equals to 2 times of the input plus 1. Besides the input values of 2, 3, 4, 5, 6, are there any other inputs? Because in the input, they only gave us 2, 3, 4, 5, 6. Are these the only possible inputs? Can I put in something else? Can I put in 0? Can I put in 1? Definitely we can. And we will get a corresponding output. Oops, sorry. So for example, when x is equal to 1, y is equal to 3. Based on the formula that Si Ting proposed. When x equals to 0, y equals to 1. Now part B, how many different values of y correspond to each value of x? when I give you an x value, how many different y will you get? Is there only one y value for each x value? According to the formula given by Siting, then yes, y equals to 2x plus 1. When x has a certain value, y will have a certain value. Y cannot have two answers for each value of x. Okay, we will not do part 6. That is, it's just exploring for part 6. Okay? Now what I instead want to do is to recreate this plane over here. Okay, which I've done. Now please tell me, is there any way that I can improve on this, whatever I've drawn so far? Anything to be improved? Yes, Harry, what should I do? What about y? Oh, I didn't write the y. You are right. I have to put the y over here. So as you can see, the horizontal axis, the vertical axis, they lie on the major line, the thicker lines. And I label every 2 cm, minimally. You can label every 1 cm also, but you don't have to. So this is actually similar to what they have in a textbook. So I'm going to start plotting. Okay, so they told us that when the input is 2, the output is 5. So block 2, level 5 is exactly here. Put a cross. Block 3, level 7. Block 4, level 9. Block 5, level 11. Block 6, level 13. Oh no, not enough space. So extend your y-axis a little. Okay, so these are my points. And now I need to join them up because they form a straight line. Notice that I drew all the way across. I didn't just stop at the first and the end point. Okay, now this graph over here, it has an equation, which is what Siting mentioned. Y equals to 2x plus 1. And I write it over here to remind myself that all the x and y values, they are connected. Now can you read to me over at this point? When x equals to 2, y equals to, what is the value of y over here? You can tell it's 5, right? Okay. Let's try another point. Over here. When x equals to 4, y equals to 9. Can you tell that from the graph? But these are points that we already knew, right? Let's try something different. Did I mark a cross over here? I didn't. But my graph, after I join these points, they pass through this point, right? Actually, this tells me something, no? It tells me that when x equals to 1, can you read from the graph? What is the y value? It is 3. You can read that this is 3, right? Compare this with the equation, y equals to 2x plus 1. Earlier on, the textbook asks us, are there other values of x? Then we say yes. Substitute x equals to 1. 2 times 1 is 2. 2 plus 1 is 3. Based on this, if we do a calculation, when x is equal to 1, y is equals to 3. That's with calculation. But I can actually get the same answer when I read from the graph. Do you understand? Okay, now, can you tell me what is this value? When x equals to 0, y equals to 1. Good. We are not limited to just integers. We can actually go this way. When x equals to 3.5, y equals to 8. Over here. So having a graph actually allows us to solve for x and y instantly. Can you imagine for this question, I give you part A, find the value of y when x equals to 0, x equals to 1, x equals to 2, x equals to 5.5, x equals to 10, x equals to 21. Of course, this equation is y equals to 2x plus 1. Can you imagine having to do all this? C, D, E, F. Then you'll be doing substitution all the way, right? If I have so many questions, that's a lot of substitution and working to do. But if you have a graph, I just need to find the x value, I get the y value really quickly, instantly. Provided you draw the correct graph. Okay? So it's important for you to draw it correctly. Moving on, back to our notes. So here, we have some properties of a linear function. A linear function is an equation that looks like this. Y equals to mx plus c. We know that both y and x, they are known as variables. They can take any form. In our table, we every time have x and y. When x equals to 0, y equals to something. When x equals to 1, y equals to something, so on and so forth. These are our variables. The value of y is determined by both the variable x as well as what you multiply xy and what you add to it. We'll look at it a bit more later on. The graph of a linear function is called a linear graph, okay? From the word linear, what do you think is the answer over here? The shape is what do you think? What is this shape? Is it a curve? No, it is a straight line. So any point on the linear graph will satisfy the equation. Any point, A, B. Okay? So when x is equal to A, y equals to B, we put it inside the equation, left hand side will be equals to the right hand side. What do I mean by that? Is there an example? No, there's no example over here. Let's go back to my graph on my graph paper. I'm going to randomly choose a point. For example, over here. It has coordinates of 2.5, y coordinate of 6. Okay, over here. Block 2.5, level 6. That's the address of this point. If I choose to substitute x equals to 2.5 and y equals to 6 into the equation, you know this equation has a left hand side and a right hand side. The left hand side is y, the right hand side is 2x plus 1, isn't it? I'm going to do a substitution. Left hand side is y, which is 6. Right hand side is 2x plus 1. So 2 times of 2.5 plus 1. We get 5 plus 1, which is 6. So this is equal to the left hand side. As long as the point exists on this line, no matter what the coordinates you substitute inside, it will satisfy. In the same manner, if a set of coordinates does not satisfy, okay, I give you a random coordinate. Let's say, let's choose a point P with coordinates 4, 3. This is an example of a point coordinates 4, 3. Let us substitute it into the equation. Left hand side, the y value is 3. Right hand side, we've got 2x plus 1. So 2 times of 4 plus 1. We get 9. This is not equal to the left hand side. Can you see that? Now since it is not equal to the left hand side, then our conclusion is that point P doesn't lie on the line. Because if it lies on the line, left hand side must be equal to right hand side. Where exactly is 4, 3? Block 4, level 3 over here. Block 4, level 3. Can you see? It is not on the line. That's why they don't satisfy. Okay, we'll need some practice to let all this sink into us. What is the relationship between an equation and a graph, as well as all the points on the graph? Your homework was given to you already, so bring your homework as well as this part 2 of your notes on Tuesday, class 10. Thank you, class.